When you unfold a map of the world and let your eyes drift across the vast blue stretches of ocean, something peculiar begins to emerge. There, in the narrow waist of the Americas, the Atlantic and the Pacific seem to lean toward one another, separated not by thousands of miles, but by a thin ribbon of land, the Isthmus of Panama. A place where geography itself appears hesitant, as if the continents almost forgot to keep the oceans apart. For centuries, that slender strip of earth stood as a barrier, unyielding, unforgiving, and absolute. To cross from one ocean to the other was not a matter of convenience, it was an ordeal. Ships departing from the eastern coasts of the Americas, bound for the west, faced a brutal decision. They could embark on the long, treacherous voyage south, braving the violent waters around Cape Horn, where storms rose without warning and waves towered like moving mountains. Or they could unload their cargo, transport it across the jungle by land, and reload it on the other side, a slow, costly, and perilous process riddled with logistical nightmares. Time was lost, fortunes were drained, lives were risked. And yet, in that very place where nature had drawn a line, humanity began to imagine something audacious, not a path around the obstacle, but straight through it. The idea of a canal across Panama was not born from romantic ambition or curiosity. It was born from necessity. In a world increasingly driven by trade, speed meant power. Shorter routes meant dominance. The ability to move goods and warships quickly between oceans was not just an advantage, it was a transformation of global dynamics. The dream was simple in theory: carve a navigable passage through the land, connect two oceans, and rewrite the rules of distance. But Panama was no ordinary terrain. In the late 19th century, the first serious attempt to turn this dream into reality began under French leadership. Inspired by the success of the Suez Canal, which had elegantly sliced through desert sands, the French believed they could replicate that triumph in Central America. On paper, it seemed plausible. In reality, it was a catastrophe waiting to unfold. Because Panama was not Suez. There was no flat, obedient desert here. Instead, there was jungle, dense, suffocating, alive with sound and shadow. Rain fell not gently, but violently, turning soil into rivers of mud. Hills rose stubbornly from the earth, layered with rock that resisted every attempt to cut through it. Rivers, especially the unpredictable Chagres, swelled with terrifying surat during storms, transforming from calm Jiran into destructive forces within hours. And then there was the enemy no one could see: disease. Yellow fever and malaria swept through the workforce like silent executioners. Workers arrived full of hope and left in coffins, if they left at all. Camps became breeding grounds for illness. Mosquitoes, barely noticed at first, proved more lethal than any engineering failure. Still, the work continued. The French pressed forward with a vision rooted in their earlier success: a sea-level canal, a direct cut from one ocean to the other, without elevation changes, without locks. It was an elegant idea, and a fatal one, because Panama would not allow it. Digging down to sea level through unstable earth under relentless rain meant constant landslides. Excavated walls collapsed back into the trenches. Progress was erased overnight. Machinery bogged down in mud. Costs spiraled out of control. Timelines stretched into uncertainty. And the deaths kept mounting. What had begun as a bold engineering project slowly unraveled into one of the greatest construction failures of the era. Thousands lost their lives, investors lost their fortunes, and eventually the French effort collapsed, leaving behind abandoned equipment, misfinished excavations, and a lingering sense that perhaps this dream was never meant to be realized. For a moment, it seemed as though the Isthmus had won. But history rarely ends where defeat seems certain. At the dawn of the 20th century, a new player entered the stage: the United States. And for them, the canal was not merely an economic opportunity, it was a strategic necessity. To control such a passage meant controlling the Surat of global trade. It meant naval dominance. It meant influence that stretched far beyond borders. But before construction could even resume, geopolitics reshaped the region itself. Panama, then part of Colombia, became the focal point of international interest. In a series of events influenced heavily by American involvement, Panama declared independence in 1903. Soon after, agreements were signed granting the United States control over a zone where the canal would be built and operated. Now, with political access and financial power secured, the Americans faced the same two formidable enemies that had defeated the French: nature and disease. But this time, however, something fundamental changed. Instead of forcing the land to submit to an idealized vision, engineers began to adapt their plans to the realities of Panama itself. The idea of a sea-level canal was abandoned. In its place came a revolutionary concept, one that would redefine the project entirely: a lock-based canal. Rather than cutting endlessly downward, ships would be lifted, raised above sea level, carried across the isthmus, and then lowered back down on the other side. It was, in essence, a massive water elevator system. This single decision transformed the project. Excavation was reduced. The terrain was no longer an enemy to conquer inch by inch, but a feature to work with. Hills could remain, partially. Valleys could be flooded. The canal would not fight the land. It would collaborate with it. But even the most brilliant engineering solution meant nothing if the workforce continued to die. And so another battle began, one not of steel and stone, but of science. For the first time on such a scale, disease prevention became central to a construction project. Researchers had begun to understand that mosquitoes were the carriers of yellow fever and malaria. This knowledge, still relatively new, became the foundation of an unprecedented public health campaign. Swamps were drained, standing water was eliminated, entire regions were fumigated, mosquito nets were distributed, strict sanitation protocols were enforced. It was not immediate, it was not easy, but slowly something remarkable happened. The death rate dropped. For the first time, workers could survive long enough to build. And with that, the canal project truly came to life. The most dramatic phase of construction unfolded in a place that would become legendary: the Culebra Cut, later known as the Galliard Cut. Here, engineers faced a series of hills that stood directly in the canal's path. To pass through meant carving a massive trench through rock and earth under conditions that seemed almost designed to resist human effort. Explosions echoed through the jungle as dynamite shattered stone. Steam shovels clawed at the earth, lifting tons of material with each movement. And everywhere, trains moved constantly, hauling debris away, returning for more, operating like the arteries of a living machine. It was relentless. Day after day, the earth was cut back, and day after day, it fought back. Landslides were frequent, unpredictable, and devastating. Entire sections of freshly dug earth would collapse without warning, burying equipment, blocking progress, and sometimes claiming lives. Workers would clear the debris, only to see the slopes crumble again. It was a cycle of destruction and persistence, a battle not won in a single victory, but through thousands of small, exhausting efforts. And then there was water. Not just the rain, but the rivers themselves, especially the Chagres. Unpredictable and powerful, it posed a constant threat. Left unchecked, it could flood the entire canal. The solution, once again, required thinking beyond conventional limits. A dam. But not just any dam, a massive structure capable of taming the river and transforming it into something useful. The result was Gatun Lake, an artificial body of water so vast it would become a central part of the canal itself. What had once been a threat became an asset. The lake served multiple purposes. It controlled flooding, it provided the immense quantities of water needed to operate the locks, and it formed a high navigable stretch through the heart of the isthmus, allowing ships to travel across what had once been jungle and hills. The locks themselves became marvels of precision engineering. Gigantic chambers, capable of holding ships hundreds of meters long, operated with a simplicity that masked their scale. Water flowed by gravity, filling and emptying the chambers without pumps. Gates opened and closed with careful timing. Ships were raised and lowered with astonishing smoothness. Yet the margin for error was almost non-existent. Inside the locks, space was tight. Ships had to be guided with extraordinary care. For decades, electric locomotives, nicknamed mules, ran along tracks beside the chambers, using cables to keep vessels